An ancient nuclear reactor that was active 2 billion years ago appears to be a myth. Maybe it's because the term reactor usually implies a man-made structure. But in this video, we are going to study a 2 billion years old nuclear reactor that changes everything. The reactor we're talking about is within the uranium-rich Earth's crust at Oklo, Gabon. Despite their modest power output, the Gabon nuclear reactors are remarkable because they spontaneously began operating around 2 billion years ago, and they continued to operate in a stable manner for up to 1 million years. Further, at the Gabon reactors, many of the radioactive products of nuclear fission have been safely contained for 2 billion years, providing evidence that long-term geologic storage of nuclear waste is feasible. The natural reactor must have annoyed nuclear scientists. The first nuclear reactor to produce electricity started in 1951, and this only produced a negligible amount of energy. The pile of rock in the ground in Oklahoma, on the other hand, created nuclear power around 2 billion years ago. The nuclear reactors you're probably familiar with use a process called fission, where atoms are split apart and energy is released in the form of heat and radiation. That's the same process that powers those terrible atomic bombs and the nuclear power plants we have today. It's driven by elements like uranium and plutonium, which can be hard to get hold of and end up as dangerous nuclear waste. However, nuclear fusion is the process by which atoms are fused together using elements that are abundant on Earth, like the hydrogen isotopes. The heat generated from nuclear fusion reactors can be used to produce steam that can power turbines and generators to create electricity. When the Earth was first formed, uranium-235 comprised more than 30% of uranium. However, uranium-238 decays much slower than uranium-235, so uranium-235 has become more and more depleted over the Earth's 4.54 billion-year history. Billions of years ago, the abundance of uranium-235 in uranium ore was high enough for a self-sustaining fission reaction to develop. So, in theory, billions of years old uranium deposit could have spontaneously developed a self-sustaining nuclear fission, assuming the uranium was concentrated enough. There was a substance, probably water, to act as a moderator, and there were no significant amounts of neutron-absorbing elements nearby. In 1972, a natural nuclear reactor was discovered in Gabon. The French had been mining uranium in Gabon, their former colony, for use in nuclear power plants. During a routine isotopic measurement of uranium ore from Gabon, the French noticed something very strange. The uranium ore did not have a uranium-235 content. This may sound like a tiny variation, but this discrepancy was very alarming for the French nuclear officials. You see, uranium-235 in Earth's crust varies very little from the average value. Since uranium-235 can be used to make nuclear bombs, it was very important to account for this missing uranium-235. Fortunately, the nuclear officials and scientists eventually discover evidence of something extraordinary: the first natural nuclear reactor ever discovered. The uranium ore was depleted in uranium-235 because 2 billion years ago some of that uranium-235 had been used up in a natural nuclear reactor. The natural nuclear fission reactors in Gabon are unique. Till date, no additional natural nuclear reactors have been discovered. Unfortunately for science, the 16 natural nuclear reactors at Oklo have been destroyed, completely mined out for their rich uranium ore. In 1997, scientist François Gauthier-Lafay and co-authors wrote a plea to the journal Nature advocating that mining of the Bangam uranium be stopped. They wrote, "The last known natural fission reactor on Earth is likely to be mined this year. Because these natural reactors are unique, at least one should be preserved for present and future research programs." All the reactors except one are located in the most important uranium deposit of Gabon's Franceville Basin, at Oklo. This deposit will be completely mined out soon, in 1998. Future work on these reactors will therefore have to rely on previously collected samples, many of which are poorly documented and are out of their geological context. Work is still possible, however, in a reactor located in the very small uranium deposit of Bangam, 30 kilometers from Oklo. We propose that this unique, scientifically important deposit be preserved for present and future research. This deposit is no less unique, and certainly more irreplaceable, than the most valued specimens from the Moon and Mars. Since the discovery of the Gabon natural nuclear reactors in 1972, scientists have been puzzling over why these reactors developed in Gabon 2 billion years ago and seemingly have developed at no other place or time on Earth. Scientists are still working to understand the Gabon reactors, but over the past 40 years, they have managed to tease out some of the details of how these nuclear reactors operated and were preserved in the geologic record. You might be wondering why natural nuclear reactors developed in uranium deposits only 2 billion years ago, when uranium-235 had already been depleted to less than 4% of uranium. Wooden fission reactors have been even more likely to develop earlier in Earth's history, when the uranium-235 levels were even higher? Remember that a high isotopic abundance of uranium-235 is just one of 4 conditions required for a natural nuclear reactor to develop. There are 4 conditions that must be met in order for a stable natural nuclear reactor to develop. 1. The natural uranium ore must have a high uranium content and must have a thickness, at least 2/3 of a meter, and a geometry that increase the probability of spontaneous, natural fission in uranium-238 inducing a self-sustaining fission reaction in uranium-235. 2. The uranium must contain a significant amount of fissionable uranium-235. 3. There must be a moderator, something that can slow down the neutrons produced when uranium fissions. 4. There must not be significant amounts of neutron-absorbing elements, such as silver or boron, which would inhibit a self-sustaining nuclear reaction in the vicinity of the uranium. Mother Nature holds tons of secrets, and we are still scratching the surface of them. We are dedicated to bringing more interesting information to you. Till then, stay curious.